Good morning, students. Welcome back to your physics class. This side Pooja Sharma, your physics teacher. I hope you all are fine, you all are healthy, doing well. Good morning, Jasmine. We are going to wait for a little more, let everybody in. Then we are going to proceed with the class today. And in today's class, we are going to begin with the next chapter. Fine. Light chapter we have done, and after that in the next two lessons, because your December exams were approaching, so light chapter के बाद था आपका electromagnetic spectrum. We have not started that, and we start doing the revision for the December examination. Fine. So today we are going to begin up with the chapter that is electromagnetic spectrum. Hanji, please mark your attendance first of all. Kindly send a message, let me know. Jasmine is there. Good morning, Aryan. Okay, so kindly be ready with your books. We are going to proceed on with electromagnetic spectrum. Hanji, good morning. Good morning, Navjot, Aryan, Jasmine. Okay, ji, let's begin up with the class electromagnetic spectrum. So what is this electromagnetic spectrum? Kindly have your book along with you. Fine. This chapter is important to understand as well as per your exam point of view, because it's going to cover almost all the waves. Fine. This is the family of the waves which we are going to study today. So one or the other question definitely comes in the exam from this chapter. Okay. And what the main question is always there, that is the first topic of this chapter which we are going to start right now. So let's begin up with the starting of the chapter. Electromagnetic spectrum is a family of waves. Electromagnetic waves all travel at same high speed in vacuum. Fine. So electromagnetic spectrum is what? It is family of waves. Many of the families are going to be covered. Many of the waves are going to be covered into it. For example, the visible one. Fine. Or you have heard about infrared. Or you have heard about ultra, UV. Ultraviolet. X-rays. Fine. So these all are going to come into this electromagnetic spectrum. Fine. We are going to understand today that which kind of wave is having how much frequency, how much wavelength, whose wavelength is more, whose wavelength is less. Fine. Chale, let's proceed on from the beginning. I'm going to read from the book. Side by side, you keep reading. The electromagnetic spectrum is a family of waves. Electromagnetic waves all travel at the same high speed in vacuum. Okay, now they have discussed this by giving one example. For example, somebody call you from some foreign, maybe from New Zealand or from America. When you are talking to the person, you hear the voice a little later. Fine. Like you say hello or whatever. The other person speaks a little later. You hear the voice a little later. Fine. That is what is based upon the rays, the traveling of the rays. Fine. So the example they have given, this high speed explains why you can have a phone call between China and New Zealand with a delay of 0.1 second before you hear the reply from the person at the other end. ज़्यादा डिले नहीं होता है. फाइन. ऐसा नहीं है कि आप फोन पे बात कर रहे हो, when you speak the other person speaks after, or you listen the voice of the other person, you listen the reply after 5 minutes or 10 minutes. ऐसा नहीं होता है. Fine. There is going to be a delay of few seconds, 0.1, 0.2, like that. Fine. But generally there is a delay. Fine. Because the reason behind is the waves. Okay, it takes the infrared signals this long to travel there and back to the optical fiber. The speed of the electromagnetic wave is 3 into 10 raised to power 8 meter per second in vacuum, approximately the same in air. This can be written conveniently as 3 into 10 raised to power 8. Okay, जो मैंने पहले ही बोल दिया. What is the speed they have mentioned? 3 and 8 zeros. Fine. Meter per second. This is the speed which they have given. अब इसको आप conveniently कैसे लिखोगे? Like you are not going to, like if somebody says 3 and 22 zeros, so you keep on drawing 0, 0, 0, 0, 0. It's not going to be like that. What you are going to do is 3 into 10 raised to power. How many zeros are there? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 zeros. So 3 into 10 raised to power 8 meter per second. If somebody is confused कि ये कैसे आया, so I'm going to talk a little more about it. First, you can write it down, or you are probably, everybody of you are having the book along with you. So please underline over there. Underline. Okay. Now let's say you have 300. Fine. I'm going to teach you that how it is like this. Let's say you have 300, or first of all, let's say you have 30. 30. You can write it as 3 into 10. 3 into 10 is 30. Fine. Okay. 10 comes how many times? 1 time. So 3 into 10 is to power 1. Okay. Similarly, let's say you have 300. We can write it as 3 into 100. और 3 और 100 को कैसे लिख सकते हैं? 3 into 10 into 10 is 100. 10 into 10 is how much? 100, है ना? So 10 comes how many times? 2 times. इसलिए दो जीरो साइन है. 10 into 10 is 100 multiplied by 3, that is 300. Fine. So we can have it as 3 into 10 raised to power 2. ये simple है, 300 है, so we can write it 300. 3 into 10 raised to power 2 नहीं लिखेंगे. But if you have 3 and after that you have 25 zeros behind that, so you are not going to write 0 0 0 0 0 and then you keep on counting कितनी zeros होंगी कितनी रह गई. Fine. So what we do is 3 into 10 raised to power 25. Similarly, here you have 3 into 10 raised to power 8. I hope it is clear here. If it is, just give me a thumbs up. I get to know. See, this is a very minute thing, but this is very important to be understood so that during numericals, during any of this kind of form, you will not be confused. Very good, Navjot. Okay, proceeding with the next. Let's read. However, for astronomical distances, the delays quickly become longer. Obviously, the distance matters. जितना distance increase होता जाएगा, उसके according, obviously, if you are at a distance apart, at some particular distance apart, थोड़ा सा delay होगा. If the distance is going to be increased, the delay is going to be a little longer. है ना? Definitely, we can understand this. Okay. However, for astronomical distances, the delays quickly become longer. Even when Mars is at its nearest to the Earth, it takes 10 minutes to send the message to a robot on the surface and receives a reply. Getting a reply from the nearest star would be 8.5 years. Got it? Because distance बहुत ज़्यादा है. So as the distance increases, the delay is going to be there, longer. Okay. The order of the electromagnetic spectrum. White light is a mixture of different colors and can be split by the prism. This you are already aware of. That is into a visible spectrum. जिसको हम क्या बोलते हैं? White light is split into 7 colors. पढ़ा था ना ये हमने? Vibgyor. You know about this? Fine. When you have white light, it passes through a prism. It's split into 7 of the colors. We have B, I, B, G, Y, O, R. Vibgyor. At the top we have red color, then we have orange, yellow, G. Green, blue, indigo, violet. Fine. So white light it's split into 7 colors. तो हम इसको क्या बोलेंगे? This is called visible light, visible spectrum. Spectrum means a pattern we get. Fine. और ये pattern क्या है? Visible है. You can easily visualize it. Fine. So this white light, when it's split into colors, this spectrum we call it as visible spectrum. All the different colors of light travel at the same speed in the vacuum, but they have the different frequencies and wavelengths. Very much important to be understood. They travel at same speed in vacuum, fine. लेकिन इनकी जो फ्रीक्वेंसीज और इनकी जो वेवलेंथ्स होंगी वो डिफर करेंगी. दैट इज द रीजन व्हाई वी हैव विबग्योर. अगर फ्रीक्वेंसीज और वेवलेंथ अलग अलग नहीं होंगी तो व्हाइट लाइट आफ्टर पासिंग थ्रू प्रिज्म आल्सो इट विल बी व्हाइट लाइट. उसमें कोई वेरिएशन नहीं आने वाला. फाइन. बट यहाँ पे क्या हुआ? व्हेन व्हाइट लाइट पासेस थ्रू प्रिज्म, तो व्हेन इट पासेस थ्रू प्रिज्म, द वन व्हिच इज हैविंग मैक्सिमम वेवलेंथ इज ओवर हियर. ठीक है? देन a little less, less, very less. Fine. So according to that only they are splitted into their different of the colors. तो इसीलिए हुआ है because they have the different frequencies, the different wavelengths. Okay. Okay, Jing. All the different colors of the light travel at the same speed in vacuum, but they have different frequencies and wavelengths. Red light has the wavelength almost twice as long as that of violet. As I have already told you, the one which is at the top is having the maximum. Fine. So this is having the maximum wavelength and this is having the minimum wavelength. I am talking about wavelength. Fine. Red is having the maximum, violet is having the minimum, and they just gave you the relation also that the red is having the wavelength almost twice as long as that of violet light. When the colors enter the glass, they all slows down, but by different amounts because of their wavelengths are slightly different. The different colors are therefore reflected through the different angles. Please underline this. The two lines which I have just read, I am going to repeat once again. When the color enters the glass, they all slow down, but by different amount. ठीक है? कोई जल्दी स्लो हो जाएगा, कोई थोड़ा लेट स्लो होगा. देयर एज पर द वेवलेंथ, एज पर द फ्रीक्वेंसीज, उसका जो पैटर्न है उसमें थोड़ा सा चेंज आएगा. सो दैट इज व्हाई रेड सबसे ऊपर आ जाता है, देन ऑरेंज, उसके बाद आएगा येलो, उसके बाद आएगा ग्रीन एंड लास्ट में आ जाएगा आपका वॉयलेट. मींस वॉयलेट स्लोज डाउन वेरी फास्ट. ठीक है ना? एंड रेड स्लोज डाउन, रेड स्लोज बट अ बिट लेटर. अच्छा, दिस इज द रीजन. रिमेंबर आपने एक 7th 8th में क्वेश्चन किया था दैट व्हाई on the emergency vehicles like on ambulance, the ambulance is written with the red color. Fine. Why don't we choose some other color? Why don't we choose green, violet, orange? ये colors क्यों नहीं use किए जाते to write ambulance? Why we prefer red color? Or you have one more question based upon it. Why red signal is called the alarm signal? कहीं पे कुछ प्रॉब्लम है, कुछ सायरन है, कोई अलार्म है. सो रिमेंबर दे आर बेसिकली यूजिंग द रेड कलर. द रीजन बिहाइंड दिस, क्योंकि इसकी वेवलेंथ है सबसे ज्यादा. फाइन. मोर द वेवलेंथ मींस इट इज गोइंग टू कवर मोर ऑफ द डिस्टेंस. फाइन. सो इफ यू हैव अ ह्यूज ट्रैफिक समवेयर एंड इन बिटवीन यू हैव अ रेड व्हीकल, वो आपको दूर से दिखाई दे जाएगा. And you get to know that, like we make it a symbol of emergency कि कुछ वहाँ पे emergency है. There is something, a red vehicle over there. We need to give the path as soon as possible to that particular vehicle. Fine. So red means it is a kind of alert symbol. Why? क्योंकि red ही क्यों use करते हैं? अब हमारा point क्या था? Why we use red? Because red is having the maximum of the wavelength. हमने अभी करा ना, वॉयलेट की मिनिमम वेवलेंथ और रेड की मैक्सिमम, और वॉयलेट से ट्वाइस ही है उसकी, जितना वॉयलेट कवर करेगा डिस्टेंस उससे भी डबल. फाइन. So that is why we use the red color. Okay, so please underline this. I'm going to read it once again. The color enters grass, they all slows down but by different amount because their wavelengths are slightly different. The different colors are therefore reflected through different angles. ठीक है ना, ये अलग अलग एंगल से रिफ्लेक्ट होंगे. See, look here. This is the prism. Light enters this bend. ये bend हुआ, ये violet था आपका. ये एक और लाइट bend हुआ, ये आपका आ गया indigo. This one. Then next bends. Fine. So their bending angles are different. The different colors are therefore reflected through different angles. Violet is reflected the most, red the least. सबसे ज्यादा जो बेंड करता है वो कौन सा? देखो लाइट आई और ये ऐसे बेंड हो गई, तो सबसे ज्यादा जो बेंड हुआ वो कौन सा है? वायलेट. और सबसे कम जो बेंड हुआ वो कौन सा है? रेड. फाइन. जो चीज जितनी कम बेंड होगी वो उतना ज्यादा डिस्टेंस कवर करेगी. फाइन. If you have to cover more distance, you have to bend less. जितना आप बेंड करते जाओगे, अपना एंगल्स बार बार चेंज करोगे, उतना आप डिस्टेंस कम ट्रेवल करोगे ना. ओके. So violet is refracted the most, red the least. अगर पेपर में आ जाए that why so? So you will be giving your answers as per their reflective angles and the wavelengths. Figure 4.38. Okay, look at the figure which is given in front of us. Figure 4.38 shows the refraction of white light through the triangular prism, which splits it into the spectrum of visible light. That is red, orange, yellow, green, indigo, blue, indigo, violet. जिसको हम बोलते हैं विबग्योर. Fine. But see the way they have written. उन्होंने विबग्योर नहीं लिखा. They write it like this. It is written like this. That is ROYGBIB. Fine. They started with R and they end with V. ताकि हमें याद करना थोड़ा इजी हो जाए, इसलिए हम इसको ऐसे पढ़ते हैं विबग्योर, क्योंकि ऐसे कुछ बना नहीं, हमने ऐसे बना दिया. फाइन. बट इफ यू आर लर्निंग इट एज विबग्योर, तो कीप दिस इन माइंड. वी विल स्टार्ट फ्रॉम द बॉटम, क्योंकि विबग्योर जो वी है दैट इज द लीस्ट वन. फाइन. तो वो बॉटम पे आएगा, टॉप पे क्या आएगा? आर आएगा. सिर्फ याद रखने के लिए विबग्योर, लिखने के लिए you have to write it like this, you have to write it like this. I hope it is understood till here. The visible spectrum is only a small part of the full electromagnetic spectrum. Okay, this is now very interesting. हमने अभी करा electromagnetic spectrum, जिसके बारे में हम पढ़ना चाह रहे हैं अभी. We said that this is a family of waves. इसमें बहुत सारी waves आती हैं and this is one of the waves. ये नहीं कि ये सारा electromagnetic. This is just one small portion of the whole electromagnetic spectrum. Fine. So the visible light is only a small part of the full electromagnetic spectrum. The electromagnetic spectrum has waves of wavelength of the order 10 raised to power 4 meter right down to wavelengths of the order 10 raised to power minus 12 meter. Visible light has the wavelength ranging between 10 raised to power minus 6 and 10 raised to power minus 7 meter. ठीक है, तो ये एक छोटा सा पोर्शन. वेरिएशन कहां से कहां तक हो रही है? 10 raised to power 4 से लेके 10 raised to power minus 12 तक. Fine. So you have 10 raised to power 4 and it goes till 10 raised to power minus 12. There is a huge variation और यहाँ पे थोड़ा सा छोटा सा कॉलम है which lies between 10 raised to power minus 6, 10 raised to power minus 7 और ये है आपका visible spectrum. Fine. There are many over here also and there are many over here as well. Okay. 10 raised to power 4, then 10 raised to power 3, 10 raised to power 2, 10 raised to power 1, 10, 10 raised to power minus 1, minus 2, minus 3, minus 4, minus 5, minus 6 is where your visible starts. Okay, all the electromagnetic waves travel at the same speed in vacuum, that is 3 into 10 raised to power 8 meter per second. That is what we have already discussed in the beginning. So I hope this is clear. ठीक है, इस पॉइंट को याद रखना और इसको अंडरलाइन कर लो प्लीज. I am repeating it once again. All electromagnetic waves travel at the same speed in the vacuum. That is 3 into 10 raised to power 8 meter per second. Fine. This question one or the other time asked in the exam. Fine. So it's not कि एग्जाम में आएगा तो हमने करना है. This is very important to be noticed. So please underline this. Okay. This means that the different wavelengths must have the different frequencies and that the longest wavelength have the smallest frequency. As shown, figure of the complete spectrum is shown in figure 4.39. Okay, 4.39 पे जाने से पहले ये पॉइंट समझ लो कि जिसकी जितनी ज्यादा वेवलेंथ होगी, वेवलेंथ एंड फ्रीक्वेंसी दे आर ऑपोजिट टू वन अनदर. फाइन. जितना ज्यादा आपका वेवलेंथ मतलब उतना कम आपका फ्रीक्वेंसी. फाइन. So the one which is having more wavelength is having the least frequency. The one which is having less wavelength is having the maximum of the frequency. Got it? Okay. Now we have the table on the next page of your book. Kindly move on to that. This is where you have to put 2, 3 of the stars. Fine. That is what I mean to say is very, very important. ये आपको टेबल पूरा ड्रॉ करना है and you have to learn it. This comes definitely, like I can say 99% it is there in your exam, either in paper 2 or in paper 4 or in paper 6, but it is there. Fine. Most of the time. And why I am saying that put star onto it, because you have to learn it. आपको ये टेबल को learn करना है. Somehow they say that draw the spectrum, but the main question which they ask for 1 or 2 marks is they will be having the spectrum already drawn on the paper. ठीक है, 4-5 portions लिखे होंगे, 3-4 blanks will be left up for you. You have to write the correct over there. Okay. Okay, so just have it onto the board. Okay, so this is the main line. Wavelength start होगी इधर से 10 raised to power 4 and it keep on decreasing, and here it is going to be the minimum, that is 10 raised to power minus 12. Fine. Okay, so we have 1, 2, 3, 4, 5, 6, 7 and this is 8. Basically आपके 8 blocks होंगे. Now you will see in your book के blocks ज़्यादा हैं. I have drawn 8. So let's do it one by one. सबसे पहले इधर आ गया आपका गामा. Gamma rays. Then you have X-rays. Fine. After X-rays, then you have UV, that is ultraviolet rays. This is your visible light. This is infrared. This is microwaves. Fine. And the last is going to be your radio waves. Okay, kindly have it onto your notebook. Or you have the book with you, आप उसी के ऊपर बस समझते जाओ, but definitely you are going to have it onto your notebook. That is electromagnetic spectrum. हाँ जी, डन बेटा. ये आपका एक कॉलम आ जाएगा. This is going to be one radio waves. Splitting I am going to clear कि क्यों हमने splitting करी हुई थी. Now if you look onto your book, अब अपनी बुक के ऊपर देखो. वहां पे है आपका गामा रेस, then you have X rays, then you have UV rays. उसके बाद आपका आया visible light. Fine. उसके बाद आपका आया इंफ्रारेड. अब आपको ये कैसे पता चलेगा कि विजिबल लाइट के इधर यूवी है कि इधर यूवी है, और which side you have UV, which side you have infrared. For that, visible light क्या है? Vibgyor. Vibgyor means Vibgyor. As I already told you, बोलने में Vibgyor बोलेंगे, लेकिन लिखने में उसको रिवर्स ऑर्डर में लिखना है. Why? Because as per the wavelength, red. देखो वेवलेंथ यहाँ से स्टार्ट हो रही है और उधर को डिक्रीज कर रही है. फाइन. तो इधर वाले पोर्शन में मैक्सिमम वेवलेंथ, मैक्सिमम किसका होता है? रेड का. और मिनिमम किसका होता है? वॉयलेट का, which I have already discussed with you. ठीक है ना? So now this is Vibgyor. फाइन. This is red और रेड के आगे इंफ्रारेड. Got it? This is violet. Violet के आगे ultraviolet. I hope you are able to make sense now. थोड़ा याद करने में easy हो जाएगा. That around this visible light, that is Vibgyor, on which side you have to write UV, on which side you have to write infrared. Infrared means red. Okay, this is red. So red के आगे क्या आएगा? You will be having infrared. This is violet. Violet के आगे you will be having here ultraviolet. Fine. Kindly draw it onto your notebook. Gamma rays, X-rays, UV, visible light, infrared, microwave, and then the last is going to be your radio. Then we are going to do the intermediate splitting. Okay. Now after you have microwave, you look onto your book. They have written ultra high frequency, very high frequency, short wave, that is short radio wave, then medium radio wave, then you have long radio wave. So that all comes over here, right? That all comes into this radio wave. जिसको हम generally क्या बोल देते हैं? We call it as radio wave, and all those are the intermediate. The portions in between this, fine. So you can have that when you draw it, or at least आपको ये पता होना चाहिए. उसके बाद यहाँ पे आप क्या करोगे? You put arrows like this, और यहाँ पे अपना next parallel line बना के split it और substitute. Substitute, what you are going to do is, where you have ultra high frequency, where you have very high frequency, short, medium, long. हाँ जी बच्चा, done? Okay, moving on with the next one. Remember, the energy associated with an electromagnetic wave depend on its frequency. Obviously, which we have discussed. दो चीजें हैं जिसके ऊपर आपका ये स्पेक्ट्रम डिपेंड करता है. One is the wavelength and one is the frequency. Fine. The energy associated with an electromagnetic wave depend on its frequency. The waves with the higher frequency are potentially the more hazardous ones. जितना ज्यादा उसका फ्रीक्वेंसी होगा ना, उतना ज्यादा कॉम्प्लिकेटेड, उतना ज्यादा प्रॉब्लम. फाइन. सो फ्रीक्वेंसी किसका ज्यादा है? Which is going to be more hazardous. If you look here, wavelength इधर है minimum, means radio waves they are having the minimum of the wavelength. Microwaves they have a little more wavelength. Infrared a little more. Then comes the visible light. Then comes the UV, X-rays, gamma. Gamma rays की जो wavelength है वो सबसे कम हो जाएगी. ठीक है ना? इधर wavelength है maximum. उसके बाद it keep on decreasing, and frequency is opposite to it. Radio waves have the maximum of the wavelength, मतलब the minimum of the frequency. और maximum frequency किधर आ जाएगी? इधर आ जाएगी. क्योंकि इधर minimum wavelength है तो इधर maximum frequency. तो कौन ज़्यादा hazardous? The one which have the most of the frequency. तो ज़्यादा frequency है gamma rays. These are going to be the more hazardous one. इसको याद रखना. In your paper 2, it can be in the form of the multiple choice question where they give you 4 of the waves with their frequencies and they will be asking you that which of the following is the most hazardous. Fine. So you have to see that which frequency is maximum, which is minimum. Maximum frequency is going to be the answer. Okay, so the energy associated with an electromagnetic wave depend on its frequency. The wave with the higher frequency are potentially the more hazardous waves because they carry the most of the energy. Wavelength decrease कर जाएगी तो energy automatically increase हो जाएगी. Frequency, सिर्फ ये याद रख लो, frequency जिसकी ज़्यादा उसकी energy ज़्यादा. The visible light region of the spectrum contain the colors range from red through orange, yellow, green, blue to violet. Infrared lies the next to red. Ultraviolet lies the next to violet. जो मैंने आपको already बता दिया that where you have to write infrared and where you have to write ultraviolet. Violet उसके आगे ultraviolet. Red उसके आगे infrared. So this, remember, is just to understand so that you will not be confused. ठीक है, ये जो आपके बुक में this is the plus point which they have is the remember portion. ठीक है, remember portions like कई बुक्स में होता है ना end में दिया होता है the points to remember. Now here in the book you have the remember after each of your topic which are the things to be noted. So जब आप suppose you are going for your exam. Fine, you have the exam coming. So these remember portions you are specially going to work on. Okay, now based upon this you have one question. Let me have one question from you and let's see who is going to answer it first. Out of the following, which has the greatest frequency? And the options are microwaves or the gamma rays. Which of the following has the greatest of the frequency? Is it microwave or the gamma rays? Very good, Navjot. The first one to answer, gamma rays. Fine. Gamma rays are having the maximum of the frequency and microwaves less. तो अगर आप बोला जाए that which is having the less of the frequency, तो आ जाएगा microwave. Which is having the most of the wavelength, microwave. क्योंकि gamma rays की frequency maximum है, तो wavelength हो जाएगी minimum. Microwave frequency minimum, so wavelength maximum. I'm talking about the two. Okay, moving on with the next topic. And obviously the last topic we have, that is the uses and hazards of electromagnetic radiations. Fine. जो main आपका content था, that is what is your electromagnetic spectrum as the name of the chapter says. So that we have done. Electromagnetic spectrum होता क्या है? This is a wave, the family of the waves which you have, and we have all these kind of waves. Fine. किसकी frequency ज़्यादा, किसकी wavelength ज़्यादा, किसकी frequency कम, whatever. We have done that all. Visible portion we have to understand the most. The reason behind is this is what we are able to see around us. Fine. So with your Okay, asking the last question. In vacuum, what is the speed of the electromagnetic waves? In vacuum, what is the speed of electromagnetic waves? Anji, who is going to give the first answer? Very good, Navjot. 3 into 10 raised to power 8 meter per second. Good job. So in vacuum, their speed is going to be same. That is 3 into 10 raised to power 8 meter per second. What do you mean by this meter per second? If I say, like, talk about a bus, speed है बस की 60 किलोमीटर पर आवर. इसका मतलब ये है कि 1 आवर में बस 60 किलोमीटर कवर कर सकती है. Fine. If the speed, if you go with the speed throughout, fine. If the bus is going with the speed of 20 किलोमीटर पर आवर, जो पॉसिबल नहीं है, बहुत स्लो डाउन वाला काम है ये, बट स्टिल मतलब in 1 hour you cover 20 kilometers. Now same way, electromagnetic spectrum in vacuum, it is 3 into 10 raised to power 8 meter per second. Means in 1 of the second per second, हर एक सेकंड में you are covering 3 into 10 raised to power 8 meters. Fine. Okay, ji. Now, the uses and the hazards we have based upon the electromagnetic spectrum, the radiations, they have written the all one by one. So this is your homework, what you have to do. एक हम करेंगे the first one, and I'm going to give you an idea that how you have to move on. Okay. You are going to keep reading and keep underlining the main uses, the main hazards. It can be asked directly in the paper for 1 mark or for 2 marks that write the true hazards or the true uses of gamma rays, of ultraviolet rays. So you must be aware of it. Fine. Okay, the first is gamma rays, which as you see in the figure 4.39 are the electromagnetic waves with the shortest of the wavelength. यहाँ से wavelength increase करें, यहाँ पे maximum है, then it keep on decreasing, और सबसे shortest किसकी है? Gamma rays. Fine. So they have the shortest of the wavelength, and therefore they have the maximum or the greatest of the frequency. तो वही है ना, अगर जिसकी वेवलेंथ ज्यादा है उसका फ्रीक्वेंसी कम है. गामा का वेवलेंथ कम है, मिनिमम है, मींस फ्रीक्वेंसी है मैक्सिमम. एंड इफ द फ्रीक्वेंसी इज मैक्सिमम, इट मींस द एनर्जी इज आल्सो मैक्सिमम. और ये हमने अभी किया, जिसकी सबसे ज्यादा एनर्जी, दैट इज गोइंग टू बी मोर हैजार्डियस एज वेल. Got it? So इधर भी कर लो, less frequency, less hazardous. Fine. This table is going to play a very important role while you answer any question based upon this, because आपको बस ये याद रखना है किसकी फ्रीक्वेंसी. देखो ये याद करने की जरूरत नहीं है कि कितनी फ्रीक्वेंसी है. Fine. If you are able to do that, good enough, go ahead. If you are not able to, at least आपको ये पता होना चाहिए कि आउट ऑफ 2 किसकी फ्रीक्वेंसी कम, किसकी ज्यादा. फॉर दैट टेबल याद होना चाहिए. फाइन. और यू मस्ट बी अवेयर ऑफ वेवलेंथ यहां से उधर को डिक्रीज करेगी. फाइन. ओके. So gamma rays, the ultra electromagnetic waves with the shortest wavelength, with the greatest frequency and the energy, are produced by radioactive nuclei. They carry more energy than X-rays and can cause cancer and mutation in the body cells. Please underline this. These are the hazards, the problems which we can have through the gamma rays. Gamma rays are frequently used in radiotherapy to kill the cancer cell. This is the use of the gamma rays. ठीक है ना? तो आपने क्या करना है? Onto your notebook, you will be making the columns like this. You will be having it like this. Gamma rays, then uses, then hazards. Similarly, the next and so. Fine. हर एक wave type उसके uses और उसके hazards. This is going to be your homework. You are going to do it and you are going to send me the work of yours. Fine. I'm going to give you you can take the time of yours. Like today it is Wednesday. You can have it till next Wednesday, because see, tomorrow we are going to have lesson. ठीक है, we have lesson today as well as tomorrow. So in tomorrow lesson आप कल तक तो ये नहीं कर पाओगे, because I know that you have the other class also to do. तो कल हम करेंगे next study. इसको थोड़ा सा study करेंगे and the next. इसको पढ़ लेना. If you have any doubt, ask me. Fine. And we are going to begin up with the next chapter in the next class. And you can submit me this work by next Wednesday. Thank you so much. Take care of yourself. Stay safe, stay healthy. Bye-bye.